with my friend?
Definitely, madam.
Kishore, you can see Professor Vijayanand Rao sir. He's a senior most professor and head of the department IT. Sir, he's Kishore sir. He's a director for Toyota right now. And you can see Dr. Mary Saujanya.
Yes.
Her area of interest is data mining and all. And you can see Dr.
Madam, good
Raj.
morning. Good morning,
Yeah.
madam.
Sir, good morning, sir. Namaste.
Sir, Kishore sir, good morning, sir.
Good morning.
We are very happy to have you here delivering a webinar. Thank you for accepting our offer.
Oh, I have my
Madam,
pleasure.
please continue, madam. Continue, madam, please.
Yes,
Yeah,
sir.
thank
Madam, start చేద్దాం
Yeah,
madam.
we'll start. Yeah.
Okay.
Okay.
Yes, sir. Yes, sir. Good morning, everybody, to the webinar on software trends in the cloud. Here we have Professor Peri Srinivas Rao Garu, Principal, Andhra University College of Engineering, Head Computer Science and Systems Engineering, Professor Kunjam Nageshwar Rao Garu, Head Information Technology and Computer Applications, Professor Vijayananda Rao Garu, faculty members and registered participants. Today, our speaker is Mr. Kishore Janalgadda, Director of Engineering, Toyota, North USA. Mr. Kishore has more than 18 years of experience in architecting and implementing small to enterprise scale solutions. He has experience in both object-oriented and functional programming in various languages such as Java, C#, C++, Kotlin, JavaScript. He has extensive experience in SDLC using waterfall model and Scrum. And Mr. Janalagadda was consultant and advisor to multiple startup ventures. He was mentor and team building specialist. He leads several teams both onshore and offshore. And Mr. Janalagadda loves writing reusable and manageable code leveraging popular patterns like Gang of Four, etc. So, with this introduction, now I request Mr. Kishore Janalgadda sir to start the session.
Thank you, Andy. Thanks for the introduction. Hello, everybody. Like I said, I'm currently working as a director of engineering at Toyota. Very exciting times. Lot of engineering effort going on. So today, what I want to do is share with you some of the new trends in the cloud. One of the divisions I lead is the public cloud platforms here at Toyota. So how things are changing in the cloud, the rapid evolvement, DevOps, and all of that. So let me know once you can see my screen. Should be seeing a presentation.
Yes, sir. Yes, sir.
Can you see it? Okay, thank you.
Yes, sir.
All right, so let's get started. So first things, this is at a high level, a simple view of the agenda. So first, I want to kind of review, what software development lifecycle is, but then and then what are the emerging trends, and then we'll walk through some examples. And there, the ultimate thing is I want you guys to have fun and take away something useful for your careers in the future. So when you join the industry, these are the emerging trends that you will see, which are new in the industry. They're evolving, and a lot of companies are adopting them, including India and outside of India. So just for a quick review, right? Software development lifecycle is nothing but once you have an idea, which is the inception, an idea is born. And then you implement that idea into a piece of software, which is the development phase. And then to ensure that it is working, you test the idea. And then eventually you put it into production, you deploy that. And once you deploy that, you have to make sure that it is working. So it's simple. It's a simple life cycle. And then these ideas mature and you iterate the process. So nothing complicated here. But this is where all the details are, and it becomes interesting as you code. For example, so this is just a big spectrum, right? And I want to show on the left-hand side, used to be the traditional style of development, what we call the legacy style. On the right-hand side, the industry has evolved, especially in the last 10 years, it has evolved significantly. Because the cloud has matured, the DevOps models have matured, and there is a lot of science behind this. So I hope I can give you as much of that learning from that. So what we'll do is, first we'll walk through a simple example, right? And then you can relate to your lab or something where you might have done coding. The simple traditional. So for example, here is your problem statement, right? Somebody will say, hey, let's, for example, in this example, I'm saying, I have a file of data, a bunch of data. Let's figure out a simple service which returns the cheapest air tickets. Not too hard, 2 destinations, and you have the rate, and the cheapest rate keeps on getting updated. All you have to do is provide a service. And thankfully, these type of information, they're only known set of cities. So your file size already 1 GB is quite a bit of data, but it is not a big data. So and the constraints here are simple things like, okay, 24 hours to do. So if someone gives a problem like this, typically as a developer, as you're a software engineer, the first thing that comes to your mind is, oh, there is a CSV file. Obviously, you'll do some sort of an interesting thing. First of all, you pick up a programming language, Java, Python, whichever you want. And first thing that hits your mind is, okay, as a developer, what do you do? So, you pick up your code, you could be using Visual Studio, you could be using, Visual Studio Code or whatever. If you're the old school VI or some, hopefully more like IntelliJ, Eclipse, something like that. So an IDE where you write your favorite language, this is a file, I don't know, maybe file input stream, buffer stream, whatever you want to do, parse the file, cache the data, store it, and expose an API. Simple string from and string to, and then you get a rate back. Doesn't look that complicated. So as a developer, once you build this, then the first thing you do, okay, I've tried out a couple of things, from Mumbai to Delhi, you get a flight, and then from Hyderabad to Mumbai, you've tested it, made sure it is okay. Then you want to push it into some place where somebody else should try it. This is where you're stepping into the area where it used to be from a lab to a larger environment. So you have customers, and these could be your friends, or these could be other customers that you might find. In the industry, you'll slowly get into, getting alpha customers, signing them up and whatnot. And you have them try out. Some people might say, hey, this is not working for me, or, it is too slow, and you go back, you fix the bugs, iterating. So again, what I want to highlight here is when you expose these things, there are 2 things that happen. One is you as a developer had to write code and put that somewhere. Then you had to deploy into a machine. It could be a machine in your own house and a static IP. That is still fine, but still it is an environment. So that you define yourself that, okay, I have to put it in a specific way, and you send out the link. Then beyond that, once you start getting some success, now you are at a point where you're checking in code, right? Now code has to have a history. What did I do yesterday versus this? So, GitHub is a popular thing, and, GitLab, whichever. Then you run into this situation where you have more than one developer because your website is popular. More people are coming. So therefore, you say, hey, this one was working on my machine. Why is it not working for you? It's a scenario. If you will hear first thing, and every developer in their life will say this once at least, it works on my machine, so it must be right. So then you realize that, okay, maybe the Java version you are using is different than the Java version the other guy is using. So now you have to have a definition properly done. And where do you deploy, right? I mean, you are deploying in one location, maybe, user lib, and maybe this other person is deploying somewhere else. So now there has to be some way of defining a contract, saying everything has to be in this place, then only it will work. So now, when that is happening, you also have to test, make sure that every new change you're able to deploy, every new change you're able to push. And you have to slowly expand. Okay, what if you were only having one machine first, then you realize it is going bigger. Now you have to put 2 machines and they have to behave the same way. And then you put 3 machines, they also have to behave the same way. So slowly you scale, and you realize that, that also means that if you putting a new machine means that you have to create a replica somehow. So same for the copy of that machine. Now that also has to become a standard. And added to that, usually security comes a little later into the life cycle, but a very important step, that we have to make sure that we have to have proper security guidelines to this. This is your typical scaling of development lifecycle, from code all the way until how we deployed and you scaled up. So now it is no longer on your laptop. So, what you started off with, maybe you had a simple Windows machine and you ran something, but now you deployed it on an Ubuntu machine. It is different. The process is different. The project threads will work differently. But the modeling will be different. So the type of errors, the type of debugging you have to do also is different. And not to mention, it is not next to you, so you have to connect to it remotely. So challenges. How do you scale? How do you move from 1 machine to 5 machines, but then work the same way? Maintain a proper security model. So you can't assume that the file is local and try to read the file. What if the file has 2 different copies on 2 different machines, right? So for one person, Mumbai to Delhi, you will say, 1,000 rupees. The other person, you will show them 2,000 rupees. Not a good customer experience. So those are the kind of things. Consistency of data is another challenge. So these things, this is where you have to, what you are slowly realizing is now there are multiple, in order to maintain this, in the traditional world, what used to happen is we used to have explicit roles. Your build engineers used to build the binary, and they always knew they had their own special scripts. They built it. It's either a jar file that you want or a war file, whichever application. They deployed it in a specific way. Your release engineers knew which machine, how to push the machine, either SCP or SSH, whichever or PowerShell, for example, for the Windows. So however they push it, and then your quality engineers, they tested it in a specific way. So each role was a different person, and as a developer, your job was you finish your coding. Now you're waiting and you're helping them out, right? The life cycle is throughout their process they are busy, but you're not busy with that work. You're busy with the next future work, or you're either supporting them. And finally, the support engineers that answer the call if the website is not working or the API is not returning the way it is, they are the ones that look it up and see what's going on. So now this has morphed from what used to be a simple 1 laptop machine to a much larger thing. And typically, if in the old world, the way it used to be, and this is when I say old world, I don't mean it's no longer there. A lot of companies still operate this way, and I'll tell you how the trend is changing in a bit. So users typically come through a load balancer. They're looking at these servers. So these are racks. These are physical machines. Somebody is actually putting them in a rack. There is electric wiring. So if you want a new server, there is actually a purchasing period of 5 to 6 months. So because you have to go to the market, buy it, and quotes and all that, get right redundant circuits, then hook them up. So that's the standard racking. Then on top of that, there's an entire database. So, now I just put a layer. I mean, it could be a caching layer in our example or data, but what if this is a distributed cache? Because remember, we said we want consistency, so we need it to be a distributed mechanism. So if you have that, then the first layer is to make sure that all machines on the rack here will get the same response from that data layer. Second thing is you also have to have a redundant backup. So now your same source code is executing what used to be on your laptop, but it now has to, somebody is responsible for making sure that this is also deployed in a specific location, which you have no control over. These are managed by teams outside of your control. Like, for example, a DBA manages the database and they upgrade, what version of the database and how they upgrade, where should they index. All of those is done by somebody else. As a developer, you are not directly, other than asking for it, you are not actually doing any of this. So because of this, there used to be long lead times. So if somebody wants to do something, for example, all I wanted was a new machine. Remember, I said 6 months before I got it. And that is, I mean, the best in market, turnaround was maybe 4 months. That is if you happen to have a machine and somebody would rack it. Database replication is a big challenge. It looks simple on paper, but it is not. I mean, I'm sure if you haven't heard of this, look at the CAP theorem. That is an interesting scenario where you have to ensure that the data replication happens properly. So these are things that you as a developer are not even thinking about, but somebody else is. And they don't necessarily always talk to you. So these are the release layers. Now, here is a view of how the kind of personas, right? As a developer, you are writing code, which is your favorite language. But that JDBC connection or whatever it is doing a whole lot of things. It is connecting to multiple machines. It is going through network layers, which you didn't even think about as a developer. Right, and somebody is building these binaries and putting them in a specific place. Then somebody is configuring the hardware. I mean, is it 4 CPUs? Is it 8 CPUs? However many what is the memory? All of the capacity planning is done by another team. So as you can see, like several personas out there that are managing each one of these things in their own way. They talk to you, but there is no automation that is going top down. So the lead time for happening all of this is usually in the order of months. So by the time we do, which is a revelation as a student, you don't see that, but when you go out into the industry, and if your company is actually doing it in the traditional way, it shouldn't surprise you that, okay, if I have to get something into production, it might take 3 months before it goes out. I didn't even, so all these are cycles, right? It's multiple weeks for QA and all of that. Now, let's look at how the industry is changing. Like when I said DevOps centric, as a developer, what changes for you from compared to the old way of doing things? Same problem statement, same exact situation. We have our 1 GB CSV file. As a developer, you still write your code. That's not going away. So when you're writing, the new difference is the third bullet point, containerization. Or if you're using cloud-specific entries, there are other software like local stack and others which replicate the cloud behavior or services on the cloud. So this one is your first difference in today's land. How will you, when you write code, you're able to actually come up with a container which in the end might represent exactly how your code might be executed, like including where will you copy the file, what other dependent software, like if you need SSL, maybe OpenSSL so-and-so version is deployed along with that. Remember the TLS 3.0 issue that happened a while ago, and we all had to pivot. Quickly fix that bug in the industry. So this is one of the classic places where you know exactly which version you're using. So then, how will you build it? Now, you as a developer are given more power. You are empowered to say, okay, you can define how exactly you can build your software. If you want a jar file, awesome. But if you want to run Maven or Gradle, okay, well, these are the commands, go run it. You can run them in exactly like if you want Ubuntu 18.0 is exactly where I want to run it, then sure, you can define that. So this is where when you commit your code into your repository, here I'm showing GitHub as an example. The ones in the gray are examples. So you could use more tools, but these are the more popular ones. There are a lot of other things. So then, as soon as you commit your code, now imagine there are 3 people in your team, and one of you committed the code. Immediately, the build is triggered based on this strategy, what we call the branching strategy. So, which means that if you committed the code into feature/Kishore or new release, so therefore anything feature/ it's going to immediately trigger the build. Make sure that the code that I check in is first of all compilable and it is working. It didn't break anything old functionality. And you bake your unit tests into it. That is another. Every box here is a measurable entity. So as a developer, as a teammate, you can look at it and say, okay, somebody checked it in. I know this build took this much time, and these are the areas where I need to improve or then you can define your agent. So for example, it never has to be that, hey, my friend Raju built it in Ubuntu 16 and I built it in Ubuntu 18, therefore it is incompatible. No, because we are both using the same exact container. We are defining that. So this becomes code in itself. The build agent becomes code too. So you define your own Docker file and all of that. Then comes reliability. So how do I know that I didn't break the other guy? So that is your unit testing and gating factor. So unless it passes a certain gating factor, you don't have to go forward. SonarQube is just a popular tool that is out there that captures these testing. Another popular tool which I'm sure you have seen is looks good to me, LGTM. So this is, in fact, when we do code reviews in the industry, that's a very popular thing. Once I'm done with the code review in a pull request, we say LGTM, which means look good to me. So then you can merge your code. So that's a very popular phrase. I'm sure you must have heard it. So this one is doing static scanning. Static scanning is if you write your software in here, for example, we said float as the returning thing, but there is a chance that if the number is large enough, you're going to get a floating point exception. So therefore you guard against these things. These are called static scans to ensure that how do you make sure the security of the software is written in such a way that software is written in such a way that you don't expose known vulnerabilities. And last, everything is versioned, right? Today your phone has software which is versioned. Everything has to be versioned. Otherwise, you don't know which one is you're using. So this is where it becomes a natural step to version in this. And you can define this. You can say, I want version so and so. It goes back and tags your Git. So you can see as a developer now, you're made aware of all these things so that you have better control and you are not dependent on somebody else configuring this for you. You and your team are configuring it. And last one, which is very popular, open source software. I mean, I've seen people, copy from Stack Overflow. I've seen people, go to GitHub and just scrape it. But that's all good if it works. But if not, there are liabilities, right? Some people might release this under a license, which is not good for the company. So this is where Open source scanning is a very popular tool where we ensure that, okay, whatever code you got is actually in line with the acceptable licensing terms. So I know as a developer, we don't care about license. I never did. I mean, but until the time I took over as leadership, and then we know that, okay, MIT license is different from Apache GPL and, you know, all those things. So, but we are not lawyers, we're software engineers. So the important phrase that I want to call out because of this cycle, it is a continuous integration cycle. So this one is one of the most popular step in the current day industry, where you have a continuous integration cycle that is making sure you have the right package ready for deployment into the environment. Now people are then choosing, now that you have a package, you need to deploy it somewhere. And somewhere people are trending towards the cloud because you have virtualization in compute. So which means, when I say virtualization, it means that you can pick and start a machine as though it is a click of a button. There is no more 6 months waiting time for my Ubuntu with GPU installed in it. If I like it, I can click that and it's going to start in the next 30 seconds. So that completely changed how people thought about software and time to market. So this, even from a product point of view, now in your careers, you will eventually become, some will become software engineers, like developers, some will become product managers, some will become project. No matter which role you are, you will be associated with some sort of a time to market. You need to launch something to the market so your company can make money. And understanding this aspect of how much time will it take for me to put something out there, which we call the lead time, is very important, no matter what role you're in. So the big win is the fact that you no longer need to figure out or buy a Palo Alto big firewall switch, you know, and figure out how to do it, or a Cisco switch. These things have become software like. So which means you just define, I need a subnet with this IP range, and this subnet should either have an internet gateway or no gateway. So which means you're completely, you know, you don't have to worry about the actual intricacies of wiring, the fiber optic, nothing. It just becomes as though it's code and you define like that, which is actually an analogy that I'm showing on the right hand side. Application is code, you write Java or Python or whatever language. Infrastructure, which I just talked about, network, machine, which machine do you want, how much storage do you want, where do you want, that also becomes code. So infrastructure as a code is the norm these days. In fact, we call these everything as code, because as much as possible, all these things, including build pipeline. Remember, we talked about how you can define your own build, control it. If you're using Jenkins, you control your Jenkins file. If you're using GitHub Actions, you can control your GitHub workflow file. So all of those become code. And ultimately, policy, security also becomes a code. Like, you know, if I am not allowed, for example, to, in the university, or, you know, if in my company, I'm not allowed to run a machine more than, you know, 2 CPUs and, 2 GB of RAM, only because, you know, cost wise, it might be more expensive. I can put a policy that says you can't do that. And that is also code. So all these are one of the reasons why cloud becomes that flexible piece where you can go ahead and join these things in a way you like. And which is one of the reasons why companies are trying to move there to iterate fast. So remember the flexibility that it brought, and in the previous step, we packaged a binary. Now the natural choice is, now we have to build our website, right? We want to make money. So this is where you have packaged versions, and then you spawn up your environment. Now spawning up an environment is another it's nothing but another code. So I just told you that infrastructure as code, right? So it's nothing but, what do you want? Do you want two machines with a network firewall in front, with something in front? Okay, it's just nothing but write the code in such a way. For some of the, if you didn't write code, the other way is some people go to the cloud. Most cloud providers like AWS and Google and all these, they provide a console. You can go there, right click and do it. But internally, it is nothing but a piece of code. There are a lot of popular tools like Terraform and AWS. You have your cloud formation templates, and those are standard tools that you can use, and you just spin those things up. So once you get your environment in a known way, then you go deploy your binary into it. So it's just nothing but equivalent of a copy. There are ways you deploy, of course. You don't want to simply copy, right? You have to make sure that it follows a process, like who copied. There has to be a trail, and when did we copy, so that we know when did version 1 change from 1 to 2, and that way there is also audit. And if version 2 has a bug, with a push of a button, we should roll back to version 1. So because remember, everything is code. So once this is deployed, something has to trigger, and automatic functional tests that trigger and make sure that, hey, this is working fine. And the results. So did all the tests pass? Did all the maybe smoke tests, did all of them pass? Then critical tests pass. Did our security testing? Now DAST is different from SAST. So SAST is static analysis. So where the code, without running the code, it looks at making sure that you don't do anything obvious. For example, if you're writing a SQL, you don't want to take input straight from the, like I was saying, from and to as strings. You don't want to say select star from this, where city equal to, and then you put a from directly as a string attachment. That is a recipe of SQL injection. If you haven't seen OWASP top 10, OWASP, that is a very popular thing that most students should be aware of. What are the top 10 security vulnerabilities? So then DAST is static analysis. If that looks at that type of code, then DAST is actually something that executes against this. It tries to do some of those attacks like CSRF and all those cross-site scripting, injection, all those things, and ensures that it is actually not penetrable. So and then once everything is done, now remember this, and the entire environment that we just built is nothing but code. You can always clean it up. So you set up the environment, at the end you remove the environment. So that is because you want to save cost. You don't want to be running the machines. And the thing about cloud is, it's great for flexibility, but you also have to watch out for costs, and it also gives you that elasticity where you can put in and pull out. Clean up after testing, that's it. And then you move on to the next, like you tested your certification happened, your QA test happened, then you move on to the next one, which is maybe production. So this is a glimpse of all the tools. I was just throwing out a lot of buzzwords. This should help you in a way. These are some examples. I mean, there are a lot of similar competition, GitLab, whatever. But I mean, for starters, as a new developer, when you go in, you're asked to follow a typically nowadays a lot of companies are doing agile style. So a sprint, and you'll have Jira tickets, and Jira is a very popular tool that is used where you follow that. Then Confluence, usually where you write your documentation or wiki or something like that, internal wiki. GitHub is a popular tool, of course. I'm sure everybody knows that where you store your code. GitHub also has some of those lightweight things like wiki and all that, but the Confluence is a lot more powerful. Then it comes to the phases of GitHub. Here the badges, the one thing I want to highlight is, when we talk about releases, as a developer, when you're looking at code in GitHub, and you'll see this with most of the popular open source packages, which version is live today, right? What is the current version, which is nothing but a badge. that comes from your successful deployment of the software. So this concept of badges is nothing but you are reflecting what is in production in your source code, which is a state. So then here I want to call out Jenkins is a very popular tool, most common open source tool that is used for building your pipelines. Same way you just write your definition Jenkins file and you do it. Nowadays GitHub Actions are picking up. That's another one. Sauce Labs, very popular. It's a bit of a commercial tool, but if you are writing a UI or anything, it goes out and it tests on a bunch of browsers and at the same time. That way, your same code can be executing. Like if you're writing JavaScript, especially or UI, those developers are more interested in that because IE behaves differently than Chrome. So that is why it's very, very useful like that. Flood.io is a recent startup, but a very popular startup because Flood.io helps you test, large amounts of data. This is load testing. That's a very popular phase of thing. Once you put your code out there, if you're expecting, 50,000 people to come and hit it, then it's a way to hit that thing. SonarQube, I told you, it's a popular tool. Again, these are things that at some point you will hit a similar tool like this or that tool itself to help move your software and actually get better at it. Most companies, and InfraCost is a open source library. I mean, the interesting thing about this is, the reason why I put it here is there are tools that are living outside of your standard GitHub, which is like SonarQube and others. They are separate services. Jenkins. InfraCost is a plugin. It's a plugin into GitHub. It actually works while you're building. It actually shows as though it is going on. Same thing with Dependabot. So these things actually pretend these things whatever code you checked in. Like if you say instead of 4 CPU machine, I'm going to go to an 8 CPU machine. That means the cost is going to go up, and it's going to help you do that. Of course, it plugs into the build pipeline. It is not actually sitting in GitHub itself. It is part of the build pipeline. That is where it runs. But it's a very popular tool. And now, as we go through this, the last one that I want to cover here is this security side. It's actually operate. Let's do operate and security. So operation, once you deploy something into production, how do you know it is running? So there are a lot of tools, and nowadays I'm going to touch on a few other concepts in a bit, but the term observability is a pretty popular term that is coming up. It is different than monitoring. Something you should be aware of, and in your career you will eventually know that once you get there, it is not just monitoring. It is monitoring, but also with tracing and logging, and so that you can figure out the state of an entire system with one shot. One such tool is Datadog, and there are several other tools like Honeycomb and a bunch of things. But this is just an example. Native tools like CloudWatch, when you go just to AWS, they have their own thing. GCP has its own thing. GCP is Google Cloud. Same thing with X-Ray. So those are things that are native to that cloud. Last part, which is the security aspect. So this is important because most companies, at least small to larger companies nowadays, are emphasizing security, and that is because you have, if you're in the cloud, chances are if you don't configure it properly, you're vulnerable for sure, because with power comes responsibility. So this is one of those things where you have to be very careful and think up front how your security model is going to work. So firewall configurations, tightening the IPs, and SSL or encryption in transit is what we call it. These are all standard things. Encryption at rest, encryption at transit, and software. You have to be on top of software vulnerabilities. So these tools that I'm mentioning here, Barracode, Qualys, Dome9. These are all very popular security tools that scan your environment for any vulnerabilities. Burp Suite is another one which is pretty popular. In fact, you should try for fun. You guys should have Burp Suite, and you'll see how you can break your APIs or whatever. It is a very popular tool, and it's even open source. So now that we discussed all these tools, right, and we said, hey, cloud is amazing, I just want to show you that the architecture of how difficult it was to get a machine, configure its rack it, wire it, to what is it that you are changing to. In the first, I'm showing 3 different ways in which you can deploy the code in the cloud, and that this is a trend. There are a lot more intricacies inside. I'm trying to not overload here. First one, this is your standard firewall. Like users are coming through a firewall, and then they are hitting an API gateway, which will say, okay, if it is slash rates, it is going to go here, slash prices, it is going to go here. So based on routing, so the URI, it goes into different places. And these are nothing but instances. So these icons that I'm pointing out is nothing but compute instances, similar virtual machines, similar to your machines in the previous release. So the top one is very similar. The only opportunity you got is this idea that you can shift left. So that when I say shift left, in the terminology of software development, typically testing, security scanning, all of them used to happen after we deploy the code. So which is in the life cycle, if you see this pipeline, which is in this sort of a pipeline, it is at the end. Now, if you can do more and more things in the beginning, as you commit the code itself, you can do, that makes it shifting left. So the way you write the software and the infrastructure is making it shift left. So that is a very popular terminology, and most people do that. So in the term of shift left, there are certain things that we did here, like quality of the code and all that, unit testing, all of that, which is shifting left. Defining the infrastructure, that is shift left too. So you're in the development phase itself, you are able to define an infrastructure. You defined that you needed a database. You defined that your database will be a small in your QA environment, a large in your production environment. So that it's nothing but a parameter, but the database is the same. If you chose Postgres, it is Postgres. MySQL. So whichever. So a load balancer, load balancer architecture is the same. It doesn't matter if you have 5 machines versus 2 machines. It doesn't matter. The functionality of the load balancer is the same, and the routing. Now that is the top layer. Now there you can take the code, whatever you used to write in on-prem and then the legacy way, get it. All you're doing is deploying them in these instances with the extra responsibility of defining your infrastructure. Similar, the second one is where you're getting into the container and Kubernetes. This example is Kubernetes. If you haven't heard, that's another popular one, K8s, so which is the way to define your cluster. How do you scale? How do you put, instead of 5 machines, 20 machines? How do you scale up and down? All those things becomes nothing but code. It's just a simple configuration file, and you go up and down. You can start and you can say, okay, at this time I want for 2 machines, but then from 9 o'clock in the morning to 5 o'clock I want 20 machines, because I know more people will come. So those kind of things. And then, for example, Google uses a lot of Kubernetes for this sort of thing. Then the last one, so Kubernetes also is very, very common. You can write the same Java code, same way, and the good thing is you can even write the exact container in your laptop. You can test it out and push it out into Kubernetes. All you're doing is just configuring it. The last one, which is different, is the serverless style. Now that is a paradigm shift. So it is different than what you used to, right? What it is you are no longer defining anything related to hardware. All you're defining is a function, which is equivalent of writing an API to yourself. Now that function can be exposed in different ways. In this example, we are saying, okay, we'll expose it as an HTTP endpoint through the API gateway. But you could tie it in and put it in front of something else. For example, when a file changes, I want this function to run. That is also a function. But you're not worried about the hardware. You're not worried about anything. And you're letting the cloud provider, all you're defining in the cloud is, I need this much capacity. When this much capacity is usually some large or whatever. And you don't care underlying whether it runs on a Linux or a Unix or whatnot. So this is also very interesting. I mean, I don't want to go too much into the hardware details of it, but some of the chips, the architecture of how intricate this is and how efficient it has become, Lambda these days, is very interesting. Same thing with the container, how the virtualization, what used to be mainly dominated with known hardware, with Intel chips and all that, now no longer the case. There are chips designed specifically for virtualization only. And last, after all this, we are deploying the monitoring, logging, and tracing. So this section, there's a new scheme of the new style of thinking called SRE. So here people are saying, okay, what used to be thought of as, okay, how do I run it in production? Like, I mean, maybe I'm not thinking capacity, maybe I'm not thinking this. Now the whole service engineering, that whole notion is becoming an engineering where you actually write proper infrastructure code, now that everything is code, so that the functionality of the machines and these things will scale to meet the demand. So here I'm just briefly highlighting what are common terms in SRE. These are things, again, you will learn and see. This is one of the more popular ones that is coming out. So DevOps, how SRE is a type of implementing the DevOps thing. So defining your SLA, but then in order to meet the SLA, you have to have service level objectives, and in order to meet the objectives, you need to have service level indicators. So now with all this, how did the personas change? So what used to be like 8 or 9 different people now became just this one developer that is writing, that has the ability to write the code, and the SRE role, which could be the developer or which could be a separate role, which is defining how to make sure that the system scales up and down. Both are code, both are residing in the same GitHub repo, but they are acting differently. So it has boiled down to this. The one thing which I forgot to mention in this slide is the database. Even database itself, like back in the day, there used to be a DBA that did database management and whatnot. But now with the services, that role also has gone extinct. So what you're having is more like things like FlyWayDB and others, which have already given flexibility to the developers to say, if I want to add a new column to a table, all I do is define a code that then it translates that to the corresponding database. So you don't even have to worry whether it is a Postgres engine or a MySQL engine or other engine. So that is all part of configuration. And with all this, in the way we defined it, now getting a more reliable system, this new branch of chaos engineering has come in. For example, Netflix is credited for starting that. How they actually run chaos engineering on their machines, bring them down, and even in production, bring them up. Make sure that they can scale. The way you defined your auto scaling, auto recovery can be tested by running these chaos monkeys, chaos gorillas. I mean, they even have chaos king kongs. So that kind of break down an entire data center. So, but that is nothing but simulating a massive outage. So with all that, cloud is powerful. I mean, absolutely, you have ubiquitous control, but you have to be very responsible when it comes with power. So you are responsible for making sure you write that software, because even infrastructure is code. You have to make sure you meet these reliability, cost optimization. We call them the pillars, well architected pillars: security, operational excellence, and performance. And DevOps, again, is not just one way. It's a way of defining things. It involves automation. We have seen Jenkins and other things which help in the automation. We've seen measurement where we at different stages, Sonar Cube or Datadog, all these help with the measurement. But it is also the culture. Like in your mind, you have to say, I want to write my code in a modular way. It should be testable. It should be modular. So you take advantage of it. So what does it do to the company, right? From it, this is a glance at what it would do. In the, like on the left hand side, it shows what used to be the case when bugs were detected, or as the cycle went in. Like each stage, if you don't have reliable testing and there is no automation, most of the manual testing and the delay in cycles, like maybe 3 features are done and you merge them at one shot. Now you're like 6 weeks after which you actually wrote the code is when somebody is testing it, and that deployment was delayed because of the way these scripts were run, and therefore the cost of that is significantly high as you go down the pipeline, especially if you put it in production and some customer is like so angry, hey, how come it's not working? That becomes a significant cost. Whereas on the right hand side, your opportunity is way higher. K represents a constant value. So if you know for a fact that so much, if a build fails, this is your standard cost to rerun it. If deployment fails, there's a constant value. But of course, in production, when something comes up, there is still a chance that some of these bugs will go through, because attaining 100% test is difficult. But at the same time, you reduce the cost significantly by doing this. So from a cost, from a dollar point of view, from an efficiency point of view, in all angles, this is important. And remember where I said, whichever role you are in, it is important that you should know exactly when this can be pushed. Will it be 3 months in this left-hand case, or will it be, in the matter of hours? In fact, one of my best teams that have done this have done it in a matter of 45 minutes. From the time an idea came to the time it went into production in front of a customer, it was 45 minutes with all the reliability going. So with that, I've left with some few.
Having any doubts, please ask Kishore General Gadda.
Kishore?
Yes.
Yeah. ఇప్పుడు చెప్పండి మేడం.
Kishore? Yeah,
Yes.
hi. It was a lovely presentation, but just a few things. Do we have any internship opportunities for our students in your company here from India or from US?
There's a branch of Toyota called Toyota Connected there, but I can find out if there are any.
Yeah. I mean, just like that for encouragement to our students, because almost all our students have been absorbed in the placements this time.
Okay, nice.
Yeah. We have IT and CSC, and we have BI6 integrated branch also. So almost all our students, in fact, 95% of our students have been absorbed.
That is nice. Congrats. Very good.
Thank you. But in fact, what we are stressing on is they should have enough knowledge, isn't it? See, getting a job at the end of the day is not the ultimate thing. We are asking them to do some more knowledge-related courses or internships like that. I'll just put a mail to you. If at all it is
Sure.
feasible, only we will see whether anyone are interested in the internships or not. Okay.
Yeah, sure. Definitely.
Yeah, that is from my side. And anyway, students, any doubts? I think either all of them have understood, or they're online.
We're already reading, so which is good. But I mean, if as a student, right? I mean, I know some of these books are these are very popular books. So the DevOps books, and it's like a story, but these are great stories that kind of show value for how you write code. It's not just a writing code, but how do you write it so that whether it is ML, I mean, especially in our world, there's a lot of autonomous and all of that happening. You really don't want us to write code where your cars can go in random ways. So you really hope for the car to do the right job. So those are the kind of quality that the code is being made.
Yes, I do understand. Yeah.
Yes, sir. Yes. Thank you, sir. Thank you so much. With a short notice, you accepted, Kishore, sir.
Thank you so much.
Thank you so much, sir, with your excellent presentation today. I thank Principal, sir, Professor P. Srinivasrao Garu, Director, Computer Center, Professor Ramasudha Garu, and my colleague, Professor D. Lalita Bhaskari, Madam, and support with their support, and all the participants who attended the session. Thank you so much, one and all. Okay, sir. Thank you so much, sir.
Thank you. Have a wonderful day.
Excellent presentation, sir. And
Kishore, from my behalf, I just again wanted to extend a warm thanks to you within a very short notice. In fact, you have accepted.
That's what I am also saying.
I prepared for my exam.
Yes. See, so after I think how many years? 20 years?
Yeah.
20 years or so. Yeah.
I don't know, Lalita. I went to engineering college when I was 5 years old, so maybe.
Then I'm also that range only, no?
That's right.
Anyway, thank you once again, Kishore. Hope to have many more academic interactions like this. Okay.
For sure.
So students, let me tell you, he is my classmate, a very naughty and intelligent guy then. And now also is the same. So once again, Kishore, thank you.
Thank you, sir. Thank you so much, sir. From on behalf of the department, I am thankful to you, sir. Thank you so much once again, sir. Thank you so much.
Awesome. Bye.
Thank you, sir. Thank you, ma'am. Thanks for the wonderful webinar.
Okay. You tell to sir, Kishore, sir. Yes, sir.
Thank you.
Sir, with your permission, we will end the call, sir.
Okay.
We will end the session, sir, with your permission.
Okay.
Okay,
Bye,
sir. Yeah. Okay, sir. Thank you so much once again, sir. Thank you. Madam, appreciation letter.